Hi Year 8 and welcome to the lesson on modelling circuits. In science we use the idea of models a lot so that we use this to explain things that are too difficult to see. We can't see inside a wire and see what's happening with the electrons, so we use a model to explain the behaviour, and it makes things easier for us to understand. An example of that you've already come across is the plum pudding model of the atom, followed by the nuclear model of the atom. Neither of them are actually what it looks like, but they explain the behaviour really well. So today what we're going to need to look at are the set of slides that you've got called modelling circuits or circuit models. Now, it starts off and there are 5 words down there that we need to be able to use today. Now you're going to see some of these words again as specific lessons later on. But we need to be clear that we're all talking about the same thing when we talk about current, potential difference that some people call voltage, but it's measured in volts, resistance, conductor, and insulator. So afterwards, there's a description of what we mean. So the flow of negative charge, the flow of electrons is the current, the potential difference, how much energy has been transferred by the current, the resistance, how difficult it is for them to get round, conductors we've already looked at, and insulators we've already looked at. So by the end of this lesson, what you need to be able to do is talk about what the different bits of a model look like on the different models. Now, models are never perfect, so we need to be able to say what is good, what allows us to understand about those models, and what their imperfections are. We have to understand the imperfections, and you might be able to make your own model and use that to predict behavior. So let's just talk about circuits quickly. So the idea of a circuit, we've got a battery or a cell, we've got a lamp, we've got a wire, and the battery provides the energy to those electrons. It provides the push, the energy that allows them to flow as a current around the wire. Now the wire and the lamp provide resistance. They make it harder for the electrons to go around. The lamp provides much more resistance than the wire. And as the electrons go through here, there's an energy transfer and we get light and heat coming out. So that's our description of the circuit. Now there has to be no gap, because otherwise, if there's a gap, the electrons can't get past. And so it's a broken circuit. It's not a complete circuit. Have a little look at voltage. So the negative charges, the electrons, remember, need energy to make them move. This energy is given to them by the battery or the cell. It gives them a push. The resistance is how difficult it is for them to get through. So metals have a very low resistance because, remember, some of you will have looked at the fact that they have delocalized electrons that can move. So let's contemplate some models. So we could suggest that we could use people as electrons. So if you imagine the whole of year 8 stood in a long line, all 306 of you stood in a long line all the way along the science corridor, through maths, down through the modern foreign languages corridor, all the way along past reception, back along the corridor with IT at the end, back up through music and around. So you're all stood maybe 4 or 5 meters apart around that corridor. Now, Mr. Collins then stands on the steps in the science corridor and hands you some chocolate as you go past. So you now have some energy. So you're carrying some energy as you go past, and you go all the way down. However, when you get to reception, year 11 is standing there and they won't let you past. And they want you to stop going past. You hand over some of the chocolate and they let you past and you keep going. So in that, Mr. Collins is providing you with some energy. You're moving evenly around the corridor. There's something difficult to get past in reception, but by handing over some of your chocolate, some of your energy, you're able to get past. So what you would then need to discuss is what in that model was the battery, what represented the current, the voltage, the lamp, and the wires. So you could have a little think about that. What you do when you go through these slides is you just write your answers on here and you talk about what was good. Did it represent a current in a circuit at all? What's really a bit rubbish about it? It's a very basic model, and how could you make it better? Then we have the central heating model. This is actually quite a good model, I think, because we've got a flow of water, a current, and we've got a boiler and a pump, which takes in the water at low pressure and cold and cold, it heats it up and it pushes it out round through there, and it gets to a radiator. Oh, my R has moved down over there, and it gets to the radiator, and the radiator is what makes your house warm, and the heat comes out of your radiator, warms up your room, and the water going out is colder on the other side than came in. So this time I'm not going to talk through this. This is just for you to do. Another one, bakery in a supermarket. So here's a bakery over here. It makes bread. It puts it in the vans. The vans come round here. The bread gets put in the supermarket. You buy it. The empty vans go back round again. Another model of a circuit. Again, for you to talk about what you think is good about that model, what isn't good about that model. So your challenge now is to come up with your own model. So here you can describe it, you can draw it, you can insert the photo, whatever it is that you want to do, okay? But you are going to come up with a model of your own that would allow someone to understand how a circuit works using all of these keywords here, okay? You need to have a battery or a cell, a current, voltage, and wires, and for each part to be represented by your model. So what you're doing today is you're going to go and have a read through this, make sure you understand these keywords, and then you're going to look at each of these models and see if you can describe what is represented by each of those things, or what represents those things. You're going to criticize the model. You're going to say what is good about it, because there are things that it does represent well, but things that really aren't explaining the idea as well as it could. And then you're going to try and design your own. Now, this is a challenge activity. If you find this too difficult, but you've done all of the other things, you can stop, okay? This is a challenge activity. Let's be really clear. What you're going to put there, photograph, you can make it out of plasticine, you can make it out of Lego. You need a model that demonstrates those different ideas, and or you can just write it in words in there. And then you're going to say what you think is particularly good about your model. You have to acknowledge that it's not perfect, because models aren't perfect. That's kind of the point here. And you're going to say that if you had more time or more resources, what would you do to make that better? Okay, so hopefully that is going to make today's lesson a little bit easier to do if you've watched that first. I'm going to attach some other videos. freesciencelessons.com, they're always good, and we're going to put a Kahoot up here as well about circuits, because now you've done simple circuits, circuit models. Now we can really get into different types of circuit and how they work after this lesson. So good luck, have a good day.